So the title of today's notes is Key Features of Linear Functions. We are still keeping with key features, but now we're moving on to more specific types of functions. And we're going to go ahead and label these notes page 11A. So the goal for today is to isolate patterns for linear functions in order to find intercepts and end behavior of given scenarios tables, graphs, or equations. So essentially what you are asked to do is, no matter what scenario you're given, is to decide if you think it's linear and then find key features of that linear function. And we're going to talk about two vocabulary words. So I'm going to put these in red. The first one is a relation. A relation is a mapping between a set of input values and a set of output values. A function is a relation, which means it's a mapping between a set of input and output values, such that for each element of the domain, and if you don't know what domain is the x values, there exists only one element in the range. And then once you have those vocabulary words written down, we are going to go to page in your textbook, page M19. It's activity 1.1, recognizing and extending patterns. Okay, and I've got that here. It should look like this. This is also going to go into the prongs of your folder, so we're going to number that 11B. So reading the scenario, it says, Miriam owns a flooring company. Her latest job involves tiling a square room. Miriam's customer, Mr. Rivera, requested a tile of alternating black, white, and gray tiles as shown. Each tile is 1 square foot. So number 1, analyze Miriam's design of a tile pattern for a square floor. Describe as many patterns as you can. So I would pause this video and take a look at these patterns, mathematically or not, write down what you notice. If you have not paused the video and you're waiting for me to give you the answers, I suggest that you pause it and give it a shot. Okay, and over here, it said, think about it. What tools can you analyze? Draw a picture, sketch a graph, create a table, write an equation. So if you did any of those, more props to you. I didn't get that far. So I did something like design number 1, design number 2, design number 3, and then I went ahead and just put design 4 so I could maybe make an expectation for the next time. So design number 1, I just said it had 1 block or 1 tile. Design 2 had 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 tiles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 tiles. Okay. I also talked about side length. So this has 1 foot side length. I'm going to put SL for side length. And then I noticed in design 2, it had 1, 2, 3 feet of side length. And then here we had 1, 2, 3, 4, 5 feet of side length. Then I wanted to see how many were being added. So in this first design, we didn't add any. So if we started off with 1 black tile, how many tiles did we add? 1, 2, 3, 4, 5, 6, 7, 8. We added 8 tiles in design 2. And then we added 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 tiles in design 3. And that's all I noticed. I did write down black, white, gray, black, white, gray, black, white, gray. So I wouldn't necessarily have to go back and figure it out the whole time. So based on our prediction, let's see, or on our patterns, let's see if we can figure out design 4. So design 4, we know we would have to add tiles here. And it's not going to be pretty. But we do know it would get bigger. Okay, so how many tiles? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So we added 24 tiles. Side length, 1, 2, 3, 4, 5, 6, 7. 7 side length. And how many total tiles? Well, I'm going to cheat, not really cheat, but do the math. So in design 2, we had 9. We added 16. We got to 25. So I'm going to have to take 25, add 24. That means you would have 49 total tiles. Okay, take a look at number 2. Sketch and design the square floor that would be 9 by 9. So take a moment and just sketch that out. If you needed to use other colors besides black, white, and gray, that would be fine. So we do know that the center tile is black. And then we'd have a row of white. And then this next row would be gray. And it doesn't have to be perfect, just so you can see the color pattern here. Gray. And then we would have black. And I'm just going to be a little messy with it. It doesn't matter. And it looks something like this. Let's take a look at the back onto page 10. It says a hotel manager wants Miriam to tile their lobby using the same design that she created for Mr. Rivera. The lobby measures 45 feet by 45 feet, and he wants the outer edge to be the same color as the center tile. Will this occur? Justify your answer. So pause the video, see if you can figure it out, and then I'll show you how I solved it. If you have not paused the video and tried to figure it out by yourself, try it now. Okay, so here it's 45 by 45. So I kind of like drew myself a square that was 40, that I just labeled 45 by 45. I'm a visual person. And then if this center tile is black per the pattern, I would need this last row to be black also. So I built myself a table, but it got kind of redundant. So I'll start it for you, and then we'll see if there's a better way. So I titled this edge length, this column. And then if it was 1, 3, 5, 7. So we noticed, or you should have noticed, that the side lengths were going up by 2. So when I created my table, I'm going to count by 2s. And I went this far. I went to 15. So we knew that the edge color would be black, and then white, and then black. No, this one was gray, sorry. Gray, and then black, white, gray, and then black, white. And then if you wanted to keep going, 17, 19, 21, black, white, gray. Why did I stop at 15? I stopped at 15 because I know that 45 would be a pattern of 15 3 times, because 15 times 3 is 45. So if on 15 the last tile is white, that would be the same thing for a 45 by 45. The first time I did this problem, I continued my table all the way out. That wouldn't be a problem if you needed to do that. So is this possible? Justify your answer. No, it is not possible. No, at 45 by 45, the outer edge is white. And then I got to thinking that was a whole lot of work just to figure out a tile pattern. So that's where we're going to make a table and a graph and see if we can write an equation. So back to your notebook page, your notebook paper. Underneath your definitions, go ahead and draw that table with that chart, or with that graph. This table, this chart, you're going to want the whole thing. And we're just going to fill it in. So if there was one, at the first design number, the side length was still 1. At the second design number, as we counted, the design was 3, and then 5, and then 7, and then it would be 9 and 11. So what's the pattern? To go from 1 to 3, we add 2. From 3 to 5, we add 2. From 5 to 7, we add 2. 7 to 9, we add 2. 9 to 11, we add 2. So when you're trying to find patterns in data, and this first difference, so you notice a first pattern here, we're going to call that a first difference pattern. It's that first difference pattern that tells you that it is going to be a line, or it is going to be linear. And let's show that on the graph over here. So the first thing we have to do is label our x and our y axes with some kind of label based on our table. So let's connect this with the word relation. So relation is an input and an output. The input you can also think of as your independent variable, or what number is going to change no matter what. And then the output is the dependent variable. And that's what number changes based on that of the independent variable. Kind of like your paycheck. Like how much money you make depends on how many hours you work. Or how long it takes you to get somewhere depends on how fast you drive. So let's think about that in this scenario. So we just said that the y is the output, which is also the dependent variable, and you don't have to label that if you don't want to. And x is the input, or the independent variable. So does the design number depend on how long the side is, or does the side length depend on the design number? In this scenario, the design number is independent because the number of tiles you need, or the number of tiles you need along a side, depends on the design number. And then we're just going to plot these points. So it's not going to be perfect. 1, 1, 2, 3, 3, 5, 4, 7, 5, 9, and 6, 11. But you can see that there's no real curve to it in either direction. Okay, underneath that table, I want you to write down linear info brain dump. And in this case, I want you to write down anything that you remember about a line. It could be a picture, it could be a formula, anything that you remember about linear functions. And there's no right or wrong answer here. I'm just going to write down what I have so you can compare it. If there's something that I have that you don't, feel free to write it down. So usually when I talk about a line, the first thing y'all think of is y equals mx plus b. I also drew some pictures. I know that if a line has a positive slope, it goes up. If a line has a negative slope, it goes down. If we have a horizontal line, that means we have no slope. And if we have a vertical line, that's an undefined slope. I also labeled from y equals mx plus b, we know that m is slope and that b is your y-intercept. And then I thought to myself, well, slope, I used slope to draw all of these pictures. So what's the slope formula? y2 minus y1 over x2 minus x1. And I refer to that as the change in y over the change in x. So the triangle is a delta symbol, which means change in. And then for that, some of you think of that as rise over run. So I wrote that down too. Okay. Flipping this paper over, so on the back of your notebook paper, I want you to draw this little table. So we need to be able to pull key information from a graph, a table, a word problem, and an equation. And what information do we need to pull out, be able to decide? Is your slope, your y-intercept, and your x-intercept. I did include the formula, the standard form of a line, because in order to graph a line, you have to be in slope-intercept form. If you're not done drawing this table, I would pause the video because I'm going to start filling it out. Okay, if you're given a graph, how do you find the slope of a line? Well, that one's easy. That's where you just find rise over run. You count up or down, and then to the right. Your y-intercept, you just look where it crosses the y-axis. For your x-intercept, that's also called your root. If a problem asks you for the roots, you're just looking to see where that crosses the x-axis. And that should be pretty easy. It's all visual. Table is new. In order to find a linear from a table, it's like we did on that table we created. You're going to find the change in y over the change in x. And if it is a first difference, then it is a linear function. How do you find a y-intercept in a table? You're looking for when x equals 0. How do you find an x-intercept? You're looking where y equals 0. For these two scenarios, down here, I want you to add something. Sometimes in the pattern, or in the graph, or in the table, you can't see your y-intercept. So you may need to follow the pattern or your slope to find the intercepts. Word problems. The ACT loves these kinds of word problems. So if you're given a word problem, how do you know what number is going to be the slope? You're looking for keywords such as for every, or if it says for each, or if it has the word per, like you get paid $10 per hour. You have to pay $12 for every ticket. You earn a commission for each painting you sell. Y-intercept is an initial amount. Or it's a starting amount. Starting amount. Or instead of the word amount, they could use value. So you make an initial investment. You make a flat fee. You pay an initial amount of $40 for a rental car, anything like that. An x-intercept is more hard to find sometimes. That's when you have a dependent variable where it equals 0. Or if a company brings in no profit. Okay. An equation, you should know this one. An equation, if you want to find the slope, the first thing you have to do is get it into y equals mx plus b. And then you just look at the m value, the slope. If you're looking for your y-intercept, you can do it one of two ways. You could get it into y equals mx plus b first. If it just gives it to you and you don't have to change the form into slope-intercept form, you can always plug 0 in for x and solve for y. So if you're given a problem in standard form and it just asks you to find the y-intercept, well, the y-intercept is when x is 0, so you're just plugging 0 in for x and solving for y. The x-intercept is when y is 0, so you plug 0 in for y and you solve for x. And then once you've got that table down, we're going to talk about writing the equation for a line if you're only given 2 points. If you're still writing, you're going to want to pause the video to catch up. Okay. If you're only given 2 points, first thing you're going to do is you're going to find the slope. And you're going to have to use that equation, which is m equals y2 minus y1 over x2 minus x1. Then you're going to plug the slope and 1 point into y equals mx plus b. You're going to solve for b. And then lastly, you are going to write your equation using the m value that you found and the b value that you found. So here's our example. We only have the points 1, 2, and 0, 5, and we need to write an equation. So if you need to, this first point is where we get x1, y1 from, and this second point is where we get x2, y2 from. And I have about a little less than half my page left, so you should have plenty of space. So over here, I'm going to work slope first. So slope is y2 minus y1 over x2 minus x1. Where do you get those numbers from? You take your second y minus your first y on top. So 5 minus 2. x2 minus x1 is 0 minus 1 on bottom. And then you do the math. So 5 minus 2 is 3. 0 minus 1 is negative 1. So that means that the slope that we're going to use is negative 3. That's your very first step. Your second step is you're going to plug the slope and 1 point into y equals mx plus b. Now I show my work every time so you can see where everything is coming from. So y equals mx plus b. We already found out that our slope is negative 3. So instead of this m, we're going to plug in negative 3. And you can pick either of these points that they give you. I usually tend to go with the first one, just to keep it consistent for me every time. I find the slope. I'm going to take the first point and the slope and plug it in here. So the y value of that point is 2. The x value of that point is 1. And what we're doing here is we are solving for b. So now we just have to do the math. So -3 times 2 times 1 is -3. That 2 over there isn't going to change. We're still solving for b. To get b by itself, I'm going to add 3 to both sides. And 2 plus 3 is 5. This cancels. B is all by itself. That was the third step. So one more time. We found the slope up here to be -3. We plugged the slope in, and this very first point, x is 1, y is 2. We did the math, the arithmetic, and we found that b was 5. The very last step is we're going to take that slope, and we're going to take this y-intercept, and in y equals mx plus b, we're going to plug in our slope, and we're going to plug in our y-intercept. So I'm going to do that color-coded for you. So y equals, instead of the m, we found -3. The x doesn't change because that's part of the slope-intercept form. And then we found the b value to be a +5. And this would be the equation of your line. Okay, finishing up this workbook, or this textbook page, number 4. Very picky Paula Perkins requests a tile floor from Miriam. She also wants the alternating black, white, gray tile pattern. However, she wants the outer edge to match her wall color. And the room is 100 by 100. I'm sorry, 101 by 101. And I think it tells you that her wall color is white. So take a second, see if you can figure out what color that center tile needs to be if she wants this outer edge to be white. Okay, and I went backwards. So I went with the outer edge, and then the next, and then the inside. So if she wants her outer edge to be white, then the next tile would have to be black, which means her center would have to be gray, because she didn't care about the pattern. She just cared about those three tile colors. So she would need a gray center tile. So again, recapping, make sure on page 11A you have all of these notes down. And then page 12 will be your examples page, and this is what page 11B should look like, more or less.